Thomas grabbed two identical-looking drills from the tool shed that morning. Within minutes on the construction site, one drill ran noticeably quieter and didn't spark like the other, and it stayed cool in his hands while the second one grew hot. The difference was so dramatic that Thomas had to know what made one brushless motor so much more efficient than the other. Thomas popped open the access panel on the sparking drill to see what made the difference. Inside, he found two small black carbon blocks pressed against a copper ring, the brushes and commutator that traditional motors rely on. The friction between the brushes and the commutator generates heat, creates electrical sparks, and causes the carbon brushes to wear down. Thomas could see the wear marks where the physical contact breaks and reconnects 50 times per rotation, creating those constant sparks he'd noticed through the vents. Each spark represents energy converted to light and heat instead of work, while the carbon dust that accumulates inside the tool comes from brush wear. It reminded him of the donkey and carrot story his grandfather used to tell. The motor was constantly chasing magnetic attraction, but losing energy with every contact. When the brushes wear down to nubs, the motor stops. Thomas realized he was holding centuries-old technology that traded simplicity for efficiency, burning away precious battery power with every spark. After seeing those worn brushes and sparks, do you think Thomas will find permanent magnets instead of brushes when he opens that quieter drill? Drop your answer in the comments below. Let's follow Thomas as he discovers what makes brushless technology so different. When Thomas cracked open the quieter drill, he found no brushes at all, just a smooth ring of copper windings surrounding permanent magnets that spun without any physical contact. The brushless design delivered the power he'd felt in his hands, more torque per watt, which explained why this lighter drill outperformed the heavier brushed one. An electronic controller board replaced the mechanical brush system, using sensors to detect the rotor's position and precisely timing electrical pulses to the windings. Thomas watched the controller automatically adjust power draw based on resistance. When drilling through soft drywall, it pulled minimal battery power, but ramped up instantly when hitting a stud. This superior efficiency, longer battery life, and eliminated maintenance made the brushless drill worth its higher upfront cost. Thomas realized he was holding the future of construction tools, technology that would eliminate the constant brush replacements, extend his battery runtime significantly, and deliver consistent power for years without the energy-wasting sparks that plagued traditional motors. Back at the tool shed, Thomas checked the price tags. The brush drill cost $89, while the brushless one was $169. The brushless drill cost more up front, but Thomas realized it would save money over time through reduced maintenance and longer lifespan. After feeling the difference in performance and understanding the technology, Thomas knew the brushless motor was worth every extra dollar. It would outlast the brush drill by years while delivering consistent power throughout every battery charge. Subscribe for more tool technology breakdowns and watch our next video comparing cordless versus corded power tools.